Download this code from codegive.com, link in the description below. Non-visual access to Linux, a comprehensive guide from boot to shutdown. This tutorial provides a detailed walkthrough of accessing and managing a Linux system without a graphical interface. This is essential for users with visual impairments, server administrators who prefer command line interfaces, or in situations where a graphical environment is unavailable or problematic. We'll cover everything from boot settings, accessibility tools, command line navigation, package management, and secure shutdown. Prerequisites ****. Basic Linux knowledge *** familiarity with the command line, basic commands like ls, cd, mkdir, rm, and text editors, like nano or 6, is beneficial. Installed Linux distribution ***. This tutorial assumes a standard Linux distribution, example Ubuntu, Debian, Fedora, CentOS, is already installed. The specific steps might vary slightly based on the distribution. Text-to-speech, TTS, software, optional but highly recommended while not strictly required. A screen reader dramatically improves the experience for visually impaired users. We'll discuss some popular options. *SSH client, optional to remotely access the Linux system. iBootloader configuration for accessibility. The first challenge is making the boot process accessible. This involves configuring the bootloader, typically grub or systemd-boot, to use a text-based console and potentially enable a screen reader at boot. Grub, Grand Unified Bootloader, configuration ****. Grub is a common bootloader in many Linux distributions. 1. Edit the grub configuration file ***. Open the grub configuration file, usually located at /etc/default/grub, using a text editor with root privileges. 2. Modify the grub_command_line_Linux_default line ***. This line controls the kernel parameters passed during boot. Modify it as follows. *console equals tty1, specifies that the system console should be tty1, the first virtual terminal. This ensures that boot messages are displayed in text mode. Without this, the system might try to use a graphical console prematurely. *no mode set, disables kernel mode setting, KMS. KMS hands off graphics initialization to the kernel early in the boot process. This can sometimes interfere with text-based consoles and early screen reader initialization. It forces the system to use a more basic, frame buffer-based display. Optional, enable a screen reader at boot, eSpeakUp example. If you want to enable a screen reader during boot, you'll need to install one and configure grub to load it. Here's how to do it with a SpeakUp, a lightweight speech synthesizer. Install a SpeakUp *. Add a SpeakUp to the grub_command_line_Linux_default line *. Or *a SpeakUp.synth equals default, tries to use a SpeakUp with a default synthesizer. *a SpeakUp.synth equals speeched, tries to use speech dispatcher. This is often needed for more complex speech synthesizers or custom configurations. You might need to experiment with different SpeakUp.synth options depending on your setup. Consult the SpeakUp documentation for more details. The important thing is that a SpeakUp needs to find a speech backend or it won't work. Note *a SpeakUp is not actively maintained and may not work perfectly on all systems. Consider using Speeched or Orca at a later stage as they're better maintained. The goal here is just to get some basic feedback at boot. 3. Update grub ***. After modifying /etc/default/grub, you must update the grub configuration. This command generates the actual grub configuration file based on the settings in /etc/default/grub. For reboot asterisk. After rebooting, you should see boot messages on the text console. If you configured a speakup, you might hear it speaking as the system boots, depending on your hardware and configuration. B. Systemd boot configuration asterisk asterisk. Systemd boot is an alternative bootloader that is becoming increasingly popular, especially in newer distributions. 1. Edit the boot entry asterisk. Systemd boot configurations are located in /boot/efi/loader/entries/. Find the relevant .conf file for your boot entry, example arch.conf, ubuntu.conf. The file name might vary. 2. Add kernel parameters to the options line asterisk. Add the console equals tty1 no mode set parameters to the options line. For example, replace your _root _partition _uuid with the actual uuid of your root partition. You can find this using bulkit. Optional, enable a screen reader at boot, a speakup. Similarly to grub, you can try to enable a speakup. 3. Reboot asterisk. As with grub, you should see boot messages on the text console, and possibly hear a speakup if it's configured correctly. 2. Logging in and setting up the environment. After the system boots, you'll be presented with a login prompt on the text console. 1. Login asterisk. Enter your username and password. If you don't hear any feedback, type carefully. The password will not be echoed to the screen for security reasons. 2. Install a screen reader, if not already installed. If you haven't already, install a more robust screen reader than a speakup. 2 popular choices are Orca and Speeched. Speeched is a speech dispatcher that acts as a bridge between applications and speech synthesizers, and Orca is a full-featured screen reader built on top of Speeched. Asterisk install Speech Dispatcher and Orca, ubuntu/debian. Asterisk install Speech Dispatcher and Orca, fedora/centos. 3. Configure Orca, or another screen reader, to start automatically asterisk. The method for starting Orca automatically varies depending on your desktop environment, if you have one, or window manager, if you're running one. Since we are aiming for a non-visual environment, we will focus on the command line. A. Using .bashrc/.zshrc***. A common approach is to add a command to your .bashrc or .zshrc file, which is executed every time you open a new terminal. Find the file in your home directory, example /home/your-username/.bashrc or /home/your-username/.zshrc. If it does not exist, create it. Add the following lines to the end of the file. This script checks if the current terminal is /dev/tty1, the first virtual terminal, and if so, it starts Orca in the background. Asterisk the and symbol runs the command in the background, so the terminal doesn't wait for Orca to finish before returning to the prompt. Important asterisk log out and log back in, or open a new terminal, for the changes to .bashrc to take effect. B. Using systemd user services ***. For a more robust and persistent solution, you can create a systemd user service to start Orca automatically at login. 1. Create a service file ***. Create a file named /.config/systemd/user/orca.service. Add the following content to the file. Description, a brief description of the service. Exec start, the command to execute when the service starts, in this case, starting Orca. Make sure the path /usr/bin/orca is correct, check the output of which Orca if needed. Asterisk wanted by equals graphical session.target, this tells system to start the service when a graphical session is started, even if the session is a text-based console. To enable and start the service asterisk. Asterisk system.user enable orca.service, enables the service so that it starts automatically at login. Asterisk system.user start orca.service, starts the service immediately. 3. Verify the service is running asterisk. This will show you the status of the orca.service user service. It should indicate that it's active and running. See test and adjust settings asterisk. Log out and back in to ensure Orca starts automatically. If you don't hear it, check the following. Asterisk verify that speech is running, system.user status speech dispatcher.service. If it's not, enable and start it, system.user enable speech dispatcher.service and end system.user start speech dispatcher.service. Asterisk check the output of system.user status orca.service for errors. Asterisk ensure that your audio output is correctly configured. Use ALSA mixer to adjust the volume levels if necessary. Asterisk adjust Orca settings, voice, speed, etc., by pressing Orca plus space to open the Orca preferences. You can navigate the menus with the arrow keys and enter. The Orca key is typically insert or caps lock. 3. Navigating and managing the system. With a screen reader running, you can now interact with the system more easily. A basic command line navigation asterisk. Asterisk ls, list directory contents lists the files and directories in the current directory. Use lsl for more detailed information, permissions, size, modification date. Asterisk cd, change directory changes the current directory. cd goes up one level. cd / goes to the root directory. cd goes to your home directory. Asterisk pwd, print working directory displays the current directory path. Asterisk mkdir, make directory creates a new directory. Asterisk remdir, remove directory deletes an empty directory. Asterisk rm, remove file deletes a file. Use rmr to delete a directory and its contents recursively, use with caution. Asterisk cp, copy copies a file. Asterisk mv, moves or renames a file or directory. Asterisk touch, create empty file creates a new empty file. Asterisk cat, concatenate displays the contents of a file. Asterisk less or more, page through a file displays a file one page at a time. Asterisk head, show the beginning of a file displays the first few lines of a file. Asterisk tail, show the end of a file displays the last few lines of a file. Be working with text editors asterisk. You'll need a text editor to edit configuration files and create documents. Nano is a simple, beginner-friendly editor, while 6, or Vim, is a more powerful, but also more complex, editor. Emacs is another powerful editor that is more accessible. Asterisk nano asterisk. Use the arrow keys to navigate, and the control key in combination with other keys for commands, example Ctrl plus X to exit, Ctrl plus O to save. Asterisk 6, or Vim. 6 has two modes, command mode and insert mode. Press I to enter insert mode, where you can type text. Press ESC to return to command mode. Some useful commands in command mode. Asterisk W, write/save. Asterisk Q, quit. Asterisk WQ, write and quit. Asterisk Q, quit without saving. Asterisk /search term, search for a term. Vim can be made more accessible with plugins like set number to show line numbers. Install Vim Enhanced if it's not already installed. Emacs Emacs uses a combination of Control and Alt, Meta, keys for commands. It's very customizable and can be made highly accessible through its own configuration. See Package Management *. Installing, updating, and removing software is essential. The commands vary depending on your distribution. *debian / ubuntu, apt. *sudo apt update, updates the package lists. *sudo apt upgrade, upgrades installed packages. *sudo apt install package name, installs a package. *sudo apt remove package name, removes a package. *sudo apt purge package name, removes a package and its configuration files. *apt search package name, searches for packages. *fedora /centos, dnf /yum. *sudo dnf update, fedora, or sudo yum update, CentOS updates the package lists and installed packages. *sudo dnf install package name, fedora, or sudo yum install package name, CentOS installs a package. *sudo dnf remove package name, fedora, or sudo yum remove package name, CentOS removes a package. *dnf search package name, fedora, or yum search package name, CentOS searches for packages. *arch Linux, pacman. *sudo pacman-cu, synchronizes package databases and upgrades the system. *sudo pacman-s package name, installs a package. *sudo pacman-r package name, removes a package. *pacman-ss package name, searches for packages. File management find powerful tool for locating files and directories. Example, find /name filename.txt searches for a file named filename.txt starting from the root directory. *grep searches for patterns within files. Example, grep search term filename.txt searches for search term within filename.txt. Use I option for case-insensitive search. *diff compares two files and shows the differences. System information and monitoring *. *uname displays kernel information. *dfh shows disk space usage. *free m shows memory usage. *top or hdop displays real-time system resource usage, CPU, memory, processes. hdop is a more user-friendly version of top. *ps auxiliary lists all running processes. *systemcl status service name shows the status of a systemed service. Example, systemcl status sshd.service. *journalcl views system logs. Journalcl.exe shows the most recent log entries with explanations. 4. Customizing accessibility. Beyond the basic setup, there are several ways to further customize your Linux system for non-visual access. A. Console fonts and colors ***. You can adjust the console font and colors for better readability. *set font * changes the console font. You can use ls/usr/share/console fonts to list available fonts. Example, set font lat15 terminus 16. Set term * changes the console colors. Example, set term for white back blue. To make these changes permanent, you can add the set font and set term commands to your .bashrc file. B. Speech Dispatcher Configuration ***. Speech Dispatcher provides a central point for managing speech synthesis. You can configure it to use different synthesizers, voices, and settings. Asterisk the main configuration file is usually located at /etc/speech-dispatcher/speech.conf. Asterisk user-specific configurations can be placed in /.speech-dispatcher/speech.conf. Asterisk you can use the spd-say command to test your speech dispatcher configuration. Spd-say hello, this is a test. C. Orca configuration ***. Orca has extensive configuration options that can be accessed through its preferences dialog, Orca plus space. You can customize *voice select the synthesizer and voice. Speech rate adjust the speaking speed. Pitch adjust the voice pitch. Punctuation level control how punctuation is spoken. Braille support configure Orca to work with Braille displays. Key bindings customize the keyboard shortcuts used by Orca. Orca stores its configuration in .conf. You can use the .conf editor graphical tool to access and modify these settings, if you have a graphical environment available, or use the settings command line tool. Bash aliases and functions *. Create aliases and functions in your .bashrc or .zshrc to simplify frequently used commands. Remote access via SSH. SSH, Secure Shell, allows you to remotely access and manage your Linux system from another computer. This is particularly useful if you want to use a screen reader on a different machine to control the Linux server. 1. Install OpenSSH server *. 2. Start and enable SSH service *. 3. Find the server's IP address *. 4. Connect from another machine *. On the client machine, use an SSH client to connect to the server. You will be prompted for your password. Once authenticated, you'll have a terminal session on the server. 6. Security considerations. Secure SSH disable password authentication use SSH keys instead of passwords for authentication. This is more secure. Generate a key pair on your client machine, SSH keygen, then copy the public key to the server's /.ssh/authorized_keys file. Disable password authentication in /etc/ssh/sshd_config by setting password authentication no. Change the default SSH port *. The default SSH port, 22, is a common target for attackers. Change it to a non-standard port in /etc/ssh/sshd_config. Use a firewall enable a firewall, example UFO on Ubuntu, firewalled on fedora /centos, and only allow SSH traffic from trusted IP addresses. Keep your system updated regularly update your system to patch security vulnerabilities. Strong passwords use strong, unique passwords for all user accounts. Regular backups backup your important data regularly. 7. Secure shutdown and reboot. Use the following commands to safely shut down or reboot your system. Shutdown reboot 8. Troubleshooting and tips. No audio output check your audio output settings using ALSA mixer. Make sure the volume is not muted and the correct sound card is selected. Screen reader not starting check the logs, journal .exe, for errors related to speech or Orca. Ensure the necessary services are enabled and running. Keyboard shortcuts familiarize yourself with the keyboard shortcuts for your screen reader and text editor. This will significantly improve your efficiency. Documentation consult the documentation for your Linux distribution, screen reader, and other tools. The documentation often contains valuable information and troubleshooting tips. 9. Code examples. Here are a few practical code examples to illustrate common tasks. 1. Bash script to check disk space usage and send an email alert ****. Save this script as disk_space_check.sh, make it executable, mod plus x disk_space_check.sh, and then schedule it to run periodically using cron, example every hour. 2. Bash function to search for files and speak the results ****. Add this function to your .bashrc or .zshrc file. Now you can use find_speak file name.txt to search for the file and hear the results spoken. The 2/dev/null redirects error messages, example permission denied, to /dev/null to avoid unnecessary speech output. Conclusion. This tutorial has provided a comprehensive guide to non-visual access to Linux, from bootup to shutdown. By configuring the bootloader, installing a screen reader, customizing the environment, and learning essential command line tools, you can effectively manage a Linux system without relying on a graphical interface. Remember to prioritize security and regularly update your system. Experiment with different configurations and tools to find what works best for you. Linux offers a wide range of accessibility options, making it a powerful and adaptable operating system for everyone. Good luck.